By show of hands, do we have any chiropractors in the house? Anybody do chiropractic for fun? Okay. Then I'm only asking because this is not really built for the freakishly tall like me, so I may need to talk to somebody afterwards. Talking about blockchain today, a very large topic. We can probably talk about this for days rather than minutes, but I'm going to try to contain the scope by really focusing on what Microsoft is doing, some of their work that they currently have on Azure, and some of the initiatives going forward. I'm going to give you some spoilers of the things that I hope to talk about, hope you come away with. There may be a quiz afterwards. I don't have any prizes other than I share my bagel, I think. If you notice, he's got blockchain. I've had my eye on that myself. So the four things I want to take away. Blockchain is a shared data layer whose history does not change. The more businesses involved, the more value blockchain brings. Two is related to one, in the sense that you kind of get a network effect when you have more people sharing common data. It kind of moves in a hockey stick as far as usefulness. We're going to talk about Azure with its rich infrastructure of offerings on blockchain. This is probably the most impactful thing that Microsoft has going on blockchain right now. There's some really good solutions that you can do from architecture, or from infrastructure, I should say. And then we'll talk about the initiatives that Microsoft has for making blockchain enterprise friendly. A couple projects, Project Bletchley, Project Coco. How are we going to do it? Well, first thing I'm going to do is give you kind of a rule of thumb for use cases. Some things where you might be able to look at it and say, where does this fit into the applications I have? This is where blockchain ostensibly started in 2009, but we're still very much in early days, it feels like, for where it is on the ecosystem that's building up. So if you're going to make that leap, if you're going to say, I would like to try blockchain, I want to give you kind of a conceptual framework of these are the things that might be worthwhile going for. Going to do just enough blockchain is what I'm calling this, and that is, don't want to get too deep in the weeds, but I would like to talk about high-level concepts for blockchain, just so we're all on the same page, and the initiative, some of the things we looked at from Microsoft actually makes sense. We have that common understanding. Talk about Microsoft, their strategy for adding value, and mix in some Azure demos as we go forward. So, before I talk about what I should consider a blockchain app, I'm going to make some assumptions. I'm assuming this is more of a enterprise, business-to-business crowd. If you're hoping to get the secret for making $1 billion in Bitcoin, I apologize, that is not something I'm going to be able to do in this talk. But if you are a developer and work within or infrastructure guy within a organization, you can look at these kind of bullet points. They're blockchain, since it's a shared data layer, you're almost always going to have more than one organization involved. What you see out in the marketplace is kind of consortium blockchains. You'll see things, banks are big on this when they're, sharing data between them. Supply chains that's another early adopter of blockchain, because when you have multiple companies sharing that kind of information, that's the sweet spot for blockchain. Exchange of value, each party has some ownership stake. So we're talking pretty typical business-to-business scenarios. Let's make that a little more concrete, talk about a use case that could really benefit from having blockchain. We've got a Airbus up here. When a sales cycle for an Airbus, United Airlines calls them up and says, hey, build me an airplane. Once that happens, a lot of people get involved, a lot of companies get involved. You can kind of see all these kind of components. I mean, you've got avionics, radar, the engines, baggage containers, and so forth. It's not just Airbus who is doing all that stuff. You've got vendors in there. You've got people bidding for different pieces of this. So I'm sure applying this to your own business, just think about situations where everybody is looking to, end up here, end up with United's paying $500 million. Airbus wants to make it for $400 million. But in the meantime, Rolls-Royce is going to have their own internal systems that says, we sold this engine to Airbus for $5 million. Airbus is going to have their own system that says, we bought this for $5 million. Talking about the same thing, but there's redundant systems, there's all that kind of work that goes in there. And beyond that, there is a lot of people whose job is just to basically say, let's make this the same. There's auditors, there's accountants, there's the people who work on the duplicate systems and so forth. If you were to have a system that said, as these transactions take place, there's one source of record and everybody agrees on it, a lot of that friction just kind of goes away. That also gives you an idea of why the business world is kind of going crazy for this, especially management. Because management typically has these kind of broad views, and they see all these kind of middlemen in the middle. The people whose, again, job is just to make sure things are the same. If that happens, if you can cut those out, then they are very, very happy. So that's a good use case. It's not always applicable. I'll take a look at something kind of a business to business, but a simpler use case that's probably not great for blockchain. Let's say that I am a sculptor. I do sculptures busts made out of cheese. My former coworker Jeremy decides to quit his job and become my manager. So I've got a business going. I'm selling 20 of these a year, 10,000 a piece. Jeremy gets 10%, I got 90%. So now we sit down and say, let's build an application to run our business. Blockchain is probably not a great idea. Why not? Because there's not a lot of that same kind of friction. A lot of people, middlemen, who we would be cutting out by having a blockchain solution on that. Low volume. We could use plenty of other options there. Between SQL Server, probably even Excel would be something that would be fine for something like this. So, past the rule of thumb piece, now let's talk about just enough blockchain. One thing I want to make sure we all understand is that blockchain is not Bitcoin or any other cryptocurrency. Blockchain was essentially a technology that came as a result of cryptocurrency, so the underpinning. But there's no hard and fast connection there. I put a quote here from Jamie Dimon, kind of purposely, because in the cryptocurrency world, Jamie is something of a hate figure. He's a eminent finance guy. He's the CEO of JP Morgan, and he's a notorious cryptocurrency skeptic as far as he's concerned. This is all going to come crashing down. That said, you'll notice that he is a blockchain enthusiast. In fact, JP Morgan created a product, Quorum, that is a blockchain for banks that's getting quite a bit of usage these days. Going to oversimplify things a little bit with talking about public versus permissioned blockchains. I'm going to talk about public blockchains as, think of those as the cryptocurrency, the Bitcoins, the Ethereums of the world. Permissioned blockchains, I might use the equivalent terminology between, you can call those private blockchains, you can call them consortium blockchains. That's more like the sweet spot where Microsoft is looking. That's, if you think of these kind of like the public internet versus kind of a partner portal intranet type thing, you know, I mean, with the public internet or public blockchain, anybody can join. You know, take your laptop, download a executable, run some configuration. You're part of a public blockchain. Consortium blockchains are more like clubs. Either you start one and invite other people, or you get invited to one yourself. And as far as just what exactly it is, I've got a fairly vanilla definition up here. I think I got this one from Wikipedia. I bolded the important parts. Blockchain is an open distributed ledger that can record transactions efficiently and verifiable and permanent way. Probably the most important part of this is that distributed ledger, that first part. So let's drill down on that for a moment. A distributed ledger, and you'll hear this fairly often when approaching blockchain, is people say, oh, blockchain is just a database. That is not a bad place to start conceptually, because as technical people, we're probably more familiar with the idea of databases and how they work versus ledgers. But so let's do a little bit of comparison. We start at relational databases. These are probably all concepts that are fairly familiar to you. You know what you're doing with it. There is something, a couple of ones that I do want to call out here. One of them being that there's mutable data. You make a mistake, you write bad data into your database. It's easy enough to update it, delete it. You have the full range of CRUD operations that you can do on a database. The databases are generally highly optimized for speed, heterogeneous data types, etc. Those ones at the bottom, I'm holding for contrasting with the databases. One thing we know about blockchain, though, is that it is distributed. So let's see if we can see how these, you're probably familiar with like the Cassandras of the world, Mongo, and so forth. Perhaps this is a closer approximation of what we're talking about when we talk about blockchain. You know, the big difference here with the distributed databases is that rather than more of a centralized control, you have a shared control. You can scale up by adding nodes. You can generally, when you have data, it's split up among these nodes. Those nodes will share control. They'll take requests, fulfill requests, etc. But otherwise, quite a few similarities. Now let's get into the backbone of blockchain concept, which is this distributed ledger. I highlighted those two bullet points because those are probably the two concepts that are most foreign as you approach this. And basically what it's saying is that your blockchain, the name of the blockchain comes from this. The fact that it's built on a sequential chain of transactions. The fact that it's immutable. We're out of the CRUD world now. There's no update, there's no delete. You write something in the ledger, that's it. Those two things are related. And I think from here, this is, if we get a visual representation, this will be a little bit easier to explain. What you see here is the public Ethereum network. This is a live look at it. Ethereum is similar to Bitcoin, has some differences we'll talk about later, but I want to use this for concepts. What we've got here is, on the right, is transactions. This can represent quite a few things. See if we can infer some of the things here. This one's probably pretty straightforward. You'll see that down here in the lower right, it says that it's 0.414 Ether. That is the cryptocurrency that runs Ethereum. So this means a transaction, somebody somewhere transferred 4.1 or 0.414 Ether to this person. And could be anywhere. Could be anywhere all over the world. Again, this is a public blockchain. So you've got these transactions coming in, and what ends up happening to those is these get packaged up and put into this sequential chain of blocks. As you see, it's 366, 367, 368. That is not coincidental. Take a look at, if we drill into one of these, we can see it's all these transactions here. So why is this important? As from databases, a lot of times how things are organized underneath the hood is kind of abstracted away. You might care if you're a DBA, but a lot of times it's just, it's writing in the transaction log. It gets, goes through maintenance. There's no real magic there. The reason it matters here is because these blocks build upon each other and are cryptographically linked, so that if you got a hold of a copy of one of these ledgers and you decided, hey, instead of this person sending Ethereum to this person, why don't I change this? Why don't I get that cryptocurrency? Again, or fulfill a contract, whatever happens to be behind these transactions. If you do that, you then break. There's, it's not coincidence that the entire thing is known as cryptocurrency, because pretty much the entire thing is built on cryptographic verification and so forth. So, a couple other things to emphasize. Notice that I changed the graphic here. This is another kind of surprise about the way the ledger is different than even a distributed database. The way this works is, if you are on this network, you have a complete copy of this ledger. So if you have a node on the Bitcoin network, you have every transaction from 2009 onwards. It's an interesting way to go. One of the things that's a hallmark of blockchain is that it prioritizes consensus over speed. It's not a great strategy to say, I want this to be as fast as possible, so I'm going to make X million copies of my data layer. But, again, the trade-offs are you have consensus and everybody has the same power. Another sort of hallmark is the full visibility of all transactions. This is especially true in your public blockchains. As you saw, we just went to a website and we saw the entire history of the Ethereum public network. So before I move on, do I have any questions on this? And the reason I ask is because this is understanding the distributed ledger, or at least having a basic understanding of it, means that you can think about how to apply it for your use cases, and everything else is kind of details, very, very rich details, but this is the backbone. So, Blockchain Explorer is another very good website, correct. Outstanding. That's a great question. That's something that is, and I'm sorry, so the question was, does this replace some of the other durable stores, some other databases, or does your architecture say, I've got some other ways to store data, and do I kind of run on the side to enhance the functionality? answer is always it depends. I think it's a these are use cases that are being created now, but we'll look a little bit deeper as to how it saves data. There's definitely some value to having state elsewhere and using that, using the blockchain as almost like a notary, almost like, this is your permanent record, but there may be other like application-based information you can hold elsewhere. Okay, sorry to interrupt. I'm very, very tight on time here. So anything else? I just want to stop for a moment here because this is such an important concept in blockchain. Mo?
Would you be able to tell me the difference between antigraph and blockchain?
Afterwards, I can. I don't want to. Don't want to get there's so many ways that I could get into too many details here. So I'm going to try to keep it high level. Okay. Now, let's talk a little bit about some of the other pieces of our definition. Talking about recording transactions efficiently and in a verifiable way. These are, there's a couple of related technologies that often fulfill this. One of them being tokenization, or I'm sorry, the broad idea is tokenization. The specific technologies are hashing, which you may already be familiar with since it's been around forever. It's almost any modern password system uses hashing in one way or another. Basically, it's taking lots of data on the left, moving it over, and then making a small digest on the right. To get at that efficiency in the situations where if you are going to download a durable record that's been going since 2009, then you're not going to want tons of data. You're going to want abbreviated data. So, got a couple different examples here where you've got a person that is identified with some unique values. You've got a device that's by different values, kind of crushes it up into digests, and then the second piece of this and goes towards the verifiability is public and private key encryption. Again, this is something not earth-shattering news for you because every time you open up a secure sockets, HTTPS website, you're doing pretty much the same thing. But like a lot of technologies in blockchain, it's used in a clever way. Whether it's identities are generally based on that private key, whether that's a device, whether it's a person. If you have that private key, then you can sign a transaction and people know it's you. You can gather value based on that identity of the private key. So again, efficiency, hashing, those have some small data there, but something like the entire Wikipedia information could come into the same size digest if you run it through this cryptographic one-way hash. The last piece we'll talk about for just enough blockchain is trust and verification. And this is something where we can easily get into the weeds, but I want to emphasize that there is that all these algorithms and so forth are meant to create trust between what transactions go on. I'll show you another kind of graphic here. We're back at the Ethereum public network or public blockchain, and a couple things to pay attention to. This is on the public network. We're at block 5,488,850,000. This is just a handful of nodes that are on the network. They're involved in transacting, and if you'll notice, they all have copies of the ledger. You see how this is 5,480,851? That matches the best block we've got here. So this is kind of the next step, because these nodes on the network have got their entire ledger and have been set up. And so now, as new transactions come in, they're putting them in. And that raises the question, how do they decide? You know what I mean? You've got all these people on the network, and they're all saying, you can see it change. They say, okay, this block of transactions, that's our next step in building our ledger. The whole thing there is to figure out a method of trust, so that as things progress, people will say, block comes in, good, I'm good. I'm going to use an example from the Bitcoin network, because that's probably one you've heard of. The way they do this is with the concept of mining. So you've got all these nodes on the network, and what the nodes are doing is, as the transactions come in, they are queuing them up. There's a queue that they can pull from. So there's, like, let's say my node is on the network. It's going to say, I'm going to grab 100 transactions that I see over here, and I'm going to build a block and see if I can tell everybody else about it. The way a node does that for Bitcoin is it basically engages in a very intense guessing game. There's, it takes what's called a nonce, runs it against different hashes. It's a very compute-intensive process, but it's also, there's definitely an element of chance. So what you're saying when they're trying to get to this of saying, making hacking less profitable than helping, is they're saying, you as a node get into this guessing game, and if you win, you're going to get Bitcoin. So they're getting paid from the network. They're instead of getting after trying to hack these things, say if you're involved and if you help the network, then you're probably going to get paid more. This has been turned out to be a very effective system. I mean, we've been going through 2009, and it has not broken yet. But it does have some downsides. Those kind of guessing games usually take very much computing power. You've probably heard that the Bitcoin network takes about as much energy as a European country each day. So that may not be sustainable. Consortium blockchains especially are starting to look at different algorithms to get to the same point of saying, as transactions come in, as blocks are built, everybody agrees. So another place we could go deep in the weeds, but if you just remember trust and verification, we should be good. I'm going to make a quick nod to the fact that we are very much in a period of Cambrian explosion for both public and private blockchains. They all seem to have kind of a little niche there. We've got Bitcoin, Ethereum, Ripple, Monero. Some of them work on privacy. Some of them work on, being backed by fiat currencies, etc. Private blockchains, Hyperledger is a big one. That's from the Linux Foundation. That's generally pushed by IBM. Corda and Quorum are bank-oriented. Ethereum's an interesting one because you'll see it's both on the public and the private. We'll talk about that in a minute, but that's, it's one of the eminent ones that was built to be kind of like a network of networks. So after just enough blockchain, let's take a look at some Azure infrastructure, shall we? The first kind of move that Microsoft has made in the space involves Azure, and I go here, the dashboard that I'm sure everybody's very familiar with, and just put in blockchain. There's an entire category of essentially templates for setting up VMs, setting up networks. I mean, Microsoft looked at the pain involved of setting up something like a consortium blockchain where you have an arbitrary number of nodes that, you know, you're going to have to coordinate different teams. You're going to have to, you know, set up a lot of software. I said, how about we do this? How about we open up to partners? You know, somebody like Emmercoin, who's that you can see they usually have their little blurb about. I think these guys are focused on censorship-proof tools. Strato Blockchain is known for their, you know, for their developer experience, etc. So have a lot of partners, and then they built their own templates as well. In fact, I'll show you one that I've, you know, this particular, what I'm going to show you now is the process of setting up a consortium. You know, this is something that takes, without Azure, would take quite a bit of effort. It would take provisioning networks, provisioning VMs, but they've pretty much reduced it down to a wizard. I'll show you some of the things you can have. I mean, some of it's just adding usernames, passwords, resource prefixes, you know, setting up resource groups. Probably pretty familiar with all this kind of stuff. Since we have so many different regions, you can make a consortium that spans across regions. You're going to, you know, you can have an arbitrary number of mining nodes in here. That's kind of what we were just looking at on the Ethereum network. Transaction nodes, size them out. And then we end up at here. And unfortunately, I'll have to type a little bit here. Let's see. Here, network ID. This is the kind of thing where you have IDs that you can share with your partners that they can get on the, even after you've established it and so forth. I thought I had it. Okay, wise guy, let's change this one. Okay. So you can kind of see you'll have some validation. It'll give you a heads up of what exactly happened. And what's also very interesting is that once you build this up with a wizard, then you can output the JSON to do the exact same thing. So this is something where you can customize it if you're standing up dev, test, QA environments. Makes it fairly straightforward. I mean, there's some really thoughtful pieces to how this is set up. Hit OK, and then do this last thing. Tell me I'm signing away my life, and create. We'll start it going. It's usually about 20, 25 minutes to go. I was hoping it would pop right out, but having tested it, it may not be done by the time I'm done, but we'll go back. Okay, so makes sense to everybody. It's Microsoft gives you acceleration for infrastructure and also works with pretty much all the big partners to say, you know, here's a marketplace that if you want to use any of those other technologies that we will allow you to. We good? Because that is the Azure offerings piece of it. To look at the last couple of initiatives for Microsoft, let's take a quick backup. Thinking about some of the things we've talked about and thinking of how these things progressed. Going to look at the public blockchain, look at Bitcoin, and this is what we can call blockchain 1.0. We've got transactions, we've got record keepers, and we end up with the ledger. This is about 2009. About 2015, you know, the blockchain come out. People were excited about it. People brought in enterprise. it wasn't a great fit. But about 2015, Ethereum came out, and that brought a couple new features that really jump-started what people thought about for permission blockchains. One of them being smart contracts. That's, if you think of a blockchain as something like a database, those would be something like stored procedures. It makes makes creating sophisticated transactions a lot easier because you can have control of flow. You can have, you can have conditions such as if gold price falls below a certain $800, then buy gold from some certain address. That was big for the development story and also for permission blockchains. Ethereum from the start said we are going to be a network of networks, and that jump-started things like, Quorum is based on Ethereum. Microsoft is big on Ethereum. They're in the Ethereum Enterprise Consortium. So that's where we are with, call that blockchain 2.0. Microsoft said, okay, how can we push this to 3.0? What are some of the challenges we have? Why would somebody not want to use this in Enterprise? Well, physical architecture is a big one. Again, it's just hard, but as you saw in the demo, they fairly quickly came out with some offerings for Azure, good solutions for that to make it easy. Logical architecture is a little more involved, just as far as when you start developing for blockchain now, you might have kind of a flashback to, say mid-90s or some of the previous architectures, because there's just some things that are not too baked. And then, so Microsoft looked at that and said, how can we improve this kind of architecture? And then enterprise controls. Microsoft has all sorts of things like the identity, cryptography, things that have been developed and have been around for a long time. So Microsoft says, let's bring this into the blockchain world and help our customers. Project Bletchley was released, or I shouldn't say released, it was announced a couple years ago. There's some very deep white papers, and there's also some fairly complicated diagrams such as this. What you'll see here is that if you think of this as a 3-level diagram, with your infrastructure at the bottom, and this is probably the interesting part is the second block there, which it's a very generic saying, here's your blockchains, here's your ledger stacks. Microsoft really wants to take this and make it the same way you would with a data layer, as you would, instead of having blockchains there in a similar diagram, you might have Oracle, you might have SQL Server. They want to be able to build a platform that when you switch out from one blockchain to another, you're still going to have the same kind of development stack on top of it. The top level there is, well, the middle level there is some of the services I talked about, identity services, crypto services, etc. You think about if there's, in most blockchain world, identity is a single key. If you think about how much trouble your company might have with username passwords, if you tell them, oh, by the way, if you lose your private key, you're no longer on the network. Probably not going to go over so well, so have a bunch of services like that. This one is somewhat fallow. They haven't heard too much for it lately because the next project has had a lot more publicity, and I'm guessing Bletchley we'll hear more about as some of the bigger conferences go. As was mentioned before, that tends to be when a lot of the big announcements come and so forth. But Project Coco is very interesting. This is also one of the differences between this and Bletchley was that Microsoft said, okay, we are interested in confidential consortiums. Let's talk about, our customers want a blockchain that they can use in their enterprise. So how do we do that? Some of the things that some of the problems they want to solve, throughput latency. I kind of hinted at that earlier. Blockchains are generally slow, but through hardware, through software, through new algorithms, they're really trying to push this towards database speeds. A related bullet point, energy use. Again, if everybody's doing the same thing Bitcoin is, at some point we run out of energy. Confidentiality is a big one. Say in our airplane example, you've got like vendor A, vendor B. They want to have their information on the blockchain, but they don't necessarily want each other to see their bids, their costs, etc. So using some of those like access control lists, things that Microsoft's been using forever, bring that to the blockchain world. Governance and code flexibility, that's just, how do I add another node to a private blockchain? And code flexibility is just kind of overcoming some of the real constraints that are in blockchain development now. I am almost out of time. Really quick, is there anybody who can tell me the 4 things I was hoping to put across? You don't want no shirt, huh? Shared data layer whose history does not change. You good at that? More business involved, the more blockchain value blockchain brings. That's when you're selecting whether an application is right for it. Ask yourself, how much stuff is involved? How much effort am I going to save? Azure has rich infrastructure offerings for blockchain. Who thinks that are still not done yet, but it's working on it. Open marketplace, accelerators, and Microsoft is aiming to make blockchain enterprise friendly. I was hoping for a bonus demo, but I have no time. The only thing, I'll publish this afterwards if you're interested in looking at some of the stuff yourself. The short answer is, from a development perspective, the Ethereum is getting big. The smart contract development is a big chunk of it. There's some things that are emerging, Solidity as a language, et cetera. But again, unfortunately, don't have too much time to get into that. If you're looking for some follow-up, especially for the Microsoft stuff, I mean, you can look at the Azure stuff yourself. It's fun to play with. You can stand up any kind of environment you want. Both Project Bletchley and Coco have fairly deep white papers and explanations of what they're up to on that. There's quite a bit of like blockchain information, not that much that's from a Microsoft perspective, but there's a Microsoft Virtual Academy course that is, it's pretty good, getting a little long in the tooth just because things are changing so quickly, but still helpful. So that's all I got. Do you have any questions before we wrap up? Could you repeat the question, please? No, this is absolutely, absolutely, and there's and especially, I mean, one thing I should point out about Bletchley and Coco is that the state both of these are in is that Microsoft working with partners, and they're doing, using real-world use cases so that they can figure it out. They're developing what's working, what's not working, and so forth. If you have a use case, and if you want to be part of this before it gets released, which is some time, you could probably talk to your favorite partner. I had one that I wanted to recommend, but I can't think of it. So, or you can contact Microsoft directly. But sorry to get off track. The main thing is that this is what they're really trying to do is make everything completely open, give a platform for those kind of things. I mean, not only in Azure, but when you have something like this, you're not going to need to actually change these, change your blockchain. You're going to have a open platform. The code is all open source. You can host it on Azure. You can host it locally. You can host it on Azure Fabric as well. It's kind of interesting for folks. So. That's yeah, the Monero stuff is kind of a fun one because we're talking about different blockchains. One of them is getting kind of infamous. Monero said, okay, we don't want to make everybody have these huge machines. Let's make it very easy to mine. And so then people said, great, I'll start putting malware on websites. Find that way. Anyway, I should probably let you go. If there's one more question. I will talk to Jason, and he will send out the links on that kind of stuff. I may not be able to put my cheese diagram in there because I'm not sure of the rights on that, but otherwise you'll get all the information. So why don't I let you go, and I'll be around. Feel free to, if you have other questions, to ask me about those. Thank you very much.